Good morning, Honors Math 2. This is my Wednesday-Thursday assignment for this week. You can complete it whenever you like. Let's see. Please find this page in your module. We're towards the end of our module 8, 8 hyperbolas, day 2. We have two standard forms of a hyperbola. I'm going to jot them at the top of my page. Okay, you can jot them down for your reference. In a hyperbola, the difference of the differences from two fixed points is always a constant. So there's always subtraction in the standard equation for a hyperbola. If the x squared term is positive, then my hyperbola branches will open left, right, like the x-axis. If the y squared term is positive, then my hyperbola branches will open up, down, like the y-axis. Both of these hyperbolas have a center at 0, 0, and then we'll move on today to some hyperbolas that do not have a center at 0, 0. Okay, so we need some extra practice on hyperbolas. Please start to get this hyperbola in standard form. To get this hyperbola in standard form, I'm going to divide through by 100 to get that right-hand side equal to 1. That first term then becomes y squared over 25 minus x squared over 4 is equal to 1. So when that y squared term is positive, that leading term is positive, I know that my branches for this hyperbola will open up, down. This is always my a squared, that first denominator. This is always my b squared. I'm going to jot down, and you can as well, what a, b, and c represent in a hyperbola. Okay, for your reference, in a hyperbola, a is always the distance from the center to the vertices. B helps us to find the slopes of our asymptotes that the branches will follow. Also helps us to form that imaginary rectangle in the middle of our hyperbola. We'll see that a lot today. And C, just like an ellipse, is the distance from the center to foci. Foci has a C in it. It's always the distance C. In this simple hyperbola, the center, since there's no HK value, is 0, 0. So let's plot the center of that hyperbola. A is always the distance from the center to the vertices. A squared is 25, A is 5, and my hyperbola branches 1, 2, 3, 4, 5. Open, up, down. 1, 2, 3, 4, 5. Okay, now I'm going to move on to B, and that's going to help me to find the slopes of my asymptotes. Notice that B is equal to 2. That gives me the slopes of my asymptotes. Again, we'll get in a little routine today so you can kind of see what happens in a hyperbola. We're not quite there yet. So notice I'm going to go up 5. That's my A value. So that means that I have to run over my B value, and my B value is 2. So rise over run, my slopes of my asymptotes are going to be plus or minus 5 over my B value, which is 2. There's that little imaginary rectangle in the middle of my hyperbola. Up 5 over 2, up 5 over 2, down 5 over 2, down 5, left 2. And there's my little rectangle. You can start to see that imaginary B value. And voila! There's the slopes of my asymptotes. If I asked you for the equations of those asymptotes, notice the slopes, equations of those asymptotes. In y equals mx plus b form, y is equal to positive 5 halves, negative 5 halves. So I say plus or minus 5 halves x. Since my center is at the origin, that's an easy case, where my y-intercept is b. So there's the equations of my asymptotes. Notice now my hyperbola is going to hug those asymptotes through the vertices and follow those asymptotes. So notice those asymptotes, that b value helps us to see how wide or narrow our hyperbola branches are. The only other thing I have to find now are my foci. So I'm going to find the foci of this hyperbola. Okay, to find the foci, it's got a C in it, I need to find C. In a hyperbola, since my foci fall inside my branches, C is always the biggest. In an ellipse, we'll start reviewing this weekend also. In an ellipse, depended which the direction my ellipse opened, if A was bigger or B was bigger. But in a hyperbola, C is always the biggest. So when I go to find C, I'm going to use this version of the Pythagorean theorem that C squared is the biggest. And I'm going to say A squared plus B squared is equal to C squared. Please solve for C. Okay, when I solved for C, C is the biggest. I got C as the square root of 29. That means that from the center, I'm going to go up root 29, down root 29, so that'll be a change in y, but my x-coordinate is still 0. Alrighty. Alright, let's get to some good ones. In this case, the hyperbola is not in standard form, so I have some good rearranging to do. Collect your y's, collect your x's, put the positive 1 out front. Okay, I'm going to collect my y's, collect my x's, and assume that's 7 to the right-hand side. We never complete the square with a coefficient. We need to factor out a negative 4. Be careful here. Divide both of those terms by negative 4. And my equation becomes, collect my y's, I'm going to complete the square, factor out a negative 4. I'm left with x squared minus 2x. Complete that square, balance, balance. What completes this square? That should be a 1. So I'm going to add 1 to the right. What completes this square should be a 1. Be careful here, I actually changed my left-hand side by a negative 4. Do the same thing on the other side, which is subtract 4. Let me start to rewrite that and write those as perfect squares. Okay, I'm at this point. When I write those as perfect squares, I need my hyperbola equation equal to 1, so I'm going to divide through by 4. And my equation becomes y plus 1 squared over 4 minus x minus 1 squared over 4, the denominator will be 1, equal to 1. Notice, will my branches open up, down, or left, right? And then I'm going to find the vertices, the foci, and the equations of the asymptotes. Since y squared is positive, just like the y-axis, my hyperbola is going to open up, down. Please notice the center of this ellipse is not at 0, 0. The center of this, hyperbola. The center of this hyperbola is, switch the sign, should be 1. Switch the sign, make sure you're putting the h with the x, and the k with the y. My center is at 1, negative 1. Please plot the center of that ellipse. Notice your a value, your b value, and eventually we'll find the c value. First denominator is always a squared, so I'm going to go up, down 2 to find my vertices. B value, second denominator is always b squared, so that's 1. That's going to help me to find the slopes of my asymptotes. Rise over run. Rise over run. Up 2 over 1, down 2, left 1. Up 2, left 1, down 2, right 1. And there's the slopes of my asymptotes. Let's find the equations of those asymptotes right away. Notice now that the slope is plus or minus 2, but they pass through the point. The center is no longer the origin. Now the center is at 1, negative 1. So my asymptotes have to pass through the point 1, negative 1. I'm going to use point slope form for my asymptotes. Why? Because it's the easiest. And I'm going to write them as y minus y, which is plus 1, is equal to the slope, plus or minus 2, times x minus 1. There's the equation of my asymptotes. Now I'm going to find the ordered pairs for my vertices and the ordered pairs for my foci. I'm going to pause so you can think about those two things. Okay, there's the equations for my asymptotes. My vertices, I usually just count off my graph. I had plotted them. So one of my vertices was at 1, 1. My other vertex is down at 1, negative 3. Please check those with me. Those are the ordered pairs for my vertices. For my foci, I have to find C. In a hyperbola, C is always the biggest. So I'm going to use this version of the Pythagorean theorem, and I'm going to stop and find my C value. Okay, I like this part. I found a C value of a square root of 5. C is always the biggest. It's the distance to those foci, and my foci always fall inside my branches. Notice my center was at 1, negative 1, but now I'm going to go up and down to my foci. So my x-coordinate is not going to change for my foci. but I was at -1 for my y value. Then I'm going to go up root 5, so I'm at -1 plus the square root of 5, and from that -1 y value, I'm going to go down root 5, so -1 minus root 5. Very nice. And those are the ordered pairs for my foci. I'm going to keep them exact. Of course, I can't plot those, but what is root 5? Root 5 is bigger than 2, so that confirms that my foci will fall inside my branches. All right, and I guess I should connect for my hyperbola. The hyperbola will pass through your vertices and follow those asymptotes. Beautiful, but we need a little more practice on that. All right, so please turn the page. Your homework today is going to be the last page of your module. It's that handwritten hyperbola extra practice sheet. I'm going to load some optional review also for this weekend, just in case you want to start reviewing the module. My plan is on my Monday-Tuesday assignment, we'll review the entire module together, and then my Wednesday-Thursday assignment will be some sort of Canvas quiz on the entire module. Alrighty, so I will load some optional review on today's assignment. The only assignment for Wednesday-Thursday is the last page of your module, Hyperbolas Day 2, but I'll load some optional practice too in case you want to start reviewing the whole module just to kind of get things set. Alrighty, I'm going to pause and you're going to start to rearrange number 3 into standard form for a hyperbola. Okay, rearrange your hyperbola. We never complete the square with a coefficient, so I'm going to factor out a 16 for my x's, and I actually factor out a -1 for my y's. Go ahead and try that. I just want to point out 9 completes my square. 9 times 16 is 144, so I'm going to add 144 to the right. This is the most common mistake, that sign right there for a hyperbola. When you factor out a -1, that should be a -8y. Complete your square. Actually change by a -16 and subtract 16. Just careful there, and now I'm going to complete this hyperbola. Okay, please check your work with mine. I get this standard equation. So I know the center is -3, 4. Since my x squared term is positive, I know that this, like the x-axis, opens left, right. This is always a squared, so a is 1, b is 4, eventually we'll find c. Right now I'm going to ask you to find the equations of the asymptotes. Y minus y1 is equal to the slope times x minus x1. Okay, since my hyperbola opens left, right, I'm going to move left 1, right 1 to my vertices. There they are, left 1, right 1. I'm just going to find my vertices right away then too. Left 1, right 1. My y-coordinate will stay the same. Now notice my slopes of my asymptotes are going to go rise my b value, run my little tiny a value. So up 4, right 1, down 4, left 1. Slopes of my asymptotes are positive or -4 over 1, passes through the point, which is my center, -3, 4. And these are my asymptotes. Please check. And to find my foci, I need c. I'm going to pause and find my c value. I get a c value of root 17, which is just more than 4. So from my center, my x value, which was -3, I'm going to move to the right root 17 and to the left root 17. I plotted my foci. My branches go through my vertices and open left, right, skimming along those asymptotes. Lovely. Thanks for working through with us. I included this last one just for practice of an ellipse. Take a minute and start to draw a picture and we'll find the equation of that ellipse. Okay, I'm going to customize this equation for a ellipse. X minus h squared plus y minus k squared. In an ellipse, this is always a squared and b squared. Alrighty, notice that my major axis is vertical. Since my foci are on it, that means that my minor axis has to be horizontal, and A was always that horizontal distance left and right of center. Okay, in our final moments, please check if you would. Here, my major axis is vertical, B is the biggest, I found B squared, and customized my equation. Plugged in my center. Please check with mine if you would, and have a great day.